Hi guys, welcome to this set of videos. What we're going to do here is we're going to continue with this theme of polynomials, and we're going to begin to look here in Chapter 5, Section 6, at a couple really important theorems when it comes to polynomials, and those theorems are the remainder theorem and the factor theorem. Now, what we did in the last section, back in Section 5, was we looked at a number of different methods for factoring a polynomial to find the zeros of the polynomial. Where does it cross the x-axis? We're actually going to continue that theme here in this section with another method for finding the zeros of a polynomial using what's known as the factor theorem. But before we jump into the factor theorem, we need to just look at the remainder theorem. And so we're going to look at both of these. Let me give you some objectives or learning targets to get started. These are the things you should be able to do by the time we get to the end of this set of videos. You'll need to be able to evaluate a polynomial function. I just wrote functions here, but of course it's going to be a polynomial. By using synthetic substitution, we'll talk about what that is. And then the last thing we're going to take a look at is this. We're going to determine whether a trinomial is a factor of a polynomial by using synthetic substitution. And I apologize, that should not say trinomial. Scratch that. That's going to be a typo. I'm sorry about that. Actually, we're going to be able to determine whether a binomial is a factor of a polynomial using synthetic substitution. So I apologize for that. It shouldn't be trinomial, binomial. So anyway, here we go. Let's start off with that first objective or learning target. And here it is right here, synthetic substitution. Okay, synthetic division can be used to find the value of a function. Here's what we're going to do. I have given you a polynomial. Well, actually, what I've done is I've given you a division of polynomials, right? This is a trinomial. This is a binomial, and I'm asking you to divide them. What I'm going to do is I'm going to do it both ways that we learned to do polynomial division. I'm going to do the algebraic division, which is very similar to long division. It uses the same process of divide, multiply, subtract, and bring down to get your quotient or the result of the division. And then we're going to do the synthetic division, because synthetic division does work for this particular polynomial. My leading coefficient is 1, that x is raised to the first power, so synthetic division works. So I'm going to do it both ways. And then the last thing I've got here for you is this idea of substitution, and you'll see why in just a second. So here we go. Let's start off right here. These are the polynomials I've asked you to divide. I've already set my problems up. Let's just jump right into it and do it. You know that the process is this. You need to divide first. So I will take the first term in my dividend and divide it by the first term in my divisor. So negative 3x squared divided by x is equal to a negative 3x. So minus 3x. And again, I line up those x to the first power. Step 2 is to multiply. So negative 3x times x gives me a minus 3x squared. And a negative 3x times a negative 3. Negative and negative is a positive. 3 times 3 is 9. So I wind up with a positive 9x plus 9x. Step number 3 is to subtract. Don't forget your parentheses so that you remember to distribute that minus sign. The first terms drop out, and they always should. If they don't, you done goofed. Go back, figure out what you did wrong. Minus sign gets distributed there, so I have 5x minus 9x, which leaves me with a negative 4x. Minus 4x. Step number 4, bring down. And we repeat the process. So now I take the first term in my reduced polynomial and divide it by the first term in my divisor. So negative 4x divided by x means I get a negative 4. And we multiply. Negative 4 times x is going to be minus 4x. Negative 4 times a minus 3 is going to be a plus 12. Yep, and then I subtract. Step number 3 is to subtract. Don't forget your parentheses so that you remember to distribute the minus sign. Those guys drop out. I distribute the minus sign, gives me a negative 12. So careful here, I have a positive 4 minus 12, which means I wind up with a negative 8. Now, This guy is going to be my remainder, negative 8, and my answer is minus 3x minus 4 minus 8 over x minus 3. Again, just let me highlight it here for you. This is our remainder. Okay, I got a remainder of negative 8. Let's go ahead and do the synthetic division for this exact same problem. Please notice I didn't need any placeholders, 2, 1, 0. So I didn't need any placeholders. I simply pull out my coefficients, negative 3, 5, and 4. And then remember how you determine what you do the synthetic division with. You set your divisor equal to 0 and solve. X minus 3 equals 0 means that x is equal to 3. And so I do my synthetic division with 3. All right, the way synthetic division works is you bring down that first term. And then it's multiply, add until you run out of numbers. 3 times a negative 3 is going to be a minus 9. 5 plus a minus 9 is going to be a negative 4. 3 times a minus 4 is a minus 12. And 4 plus a minus 12 is going to be a negative 8. And guys, remember that last number, right, is always your remainder. Your solution will always be your quotient will always be 1 less than the degree of the polynomial you were originally given. The degree of the polynomial I was originally given was a second degree polynomial. So my quotient is going to be a first degree polynomial, which means minus 3x minus 4 minus 8 over x minus 3. Please notice I get the exact same answer for both. You should. You're essentially doing the exact same thing, and this right here is your remainder. Okay, so algebraic division, synthetic division, right? You should be comfortable doing both. What I want you to see here is this guy right here. Here's what's kind of impressive. So what we're going to now do is I'm going to ask you guys to do a substitution, all right? I have taken the polynomial that you were given, right? This polynomial right up here, which was the negative 3x squared plus 5x plus 4, right? Negative 3. And I've substituted 3 for x. Why? Well, because I did synthetic division with a 3, right? That divisor set it equal to 0, solve, I get 3. So I'm going to substitute a 3 into the polynomial, right? I'm doing a substitution. And so when I substitute that 3 in for all of my x's, we go ahead and solve this guy, which means evaluate this guy. All right, so 3 squared is 9, so I have minus 3 times 9. 5 times 3 is 15, so plus 15 plus 4. Negative 3 times 9 is going to be a minus 27. 15 plus 4 is going to be a 19. And would you look at that? A negative 27 plus 19 gives you minus 8. Where have we seen that? Yeah. Right, mind's blown, right? What kind of kung fu ninja math stuff is going on here? Well, actually, it turns out it's not a trick. You'll see here in a second what this is. But what I want you to see, all right, what I want you to see before we talk about this idea of synthetic substitution, here's what I want you to see. When you do whether an algebraic or synthetic division, the remainder, what's left over after doing the division, is exactly the same thing you get by doing substitution into that polynomial. And here's what we call that. So please notice the value of f of 3, right, when I substituted a 3 into the polynomial is the same as the remainder when the polynomial is divided by x minus 3, right? I get the same answer. I got a negative 8 when I did substitution, and negative 8 was my remainder when I did both the algebraic and the synthetic division. This illustrates what we call the remainder theorem, the remainder theorem. So guys, here's what you're going to do. We are going to apply this remainder theorem using synthetic division. So you're going to do synthetic division to evaluate a function, and this is known as synthetic substitution. Okay, so here's the idea, right? What I'm asking you guys to do is to evaluate a polynomial. Now, normally when you evaluate a polynomial, you take the domain value, you plug the domain value in for the variables, right? You evaluate and you get out your numerical answer, right? That's how you evaluate a polynomial. What I'm going to ask you to do now instead is do synthetic division to do the exact same thing. I know, thanks to this example problem I just showed you, when I do synthetic division, the remainder, what's left over, is the exact same answer I would get if I did substitution. All right? So what you're going to do here is instead of doing substitution, you'll do synthetic division. And that remainder, that answer, that what's left over after you do the synthetic division is exactly what you would have gotten if you had done the substitution. Now, you may at this point be thinking, well, why? Why not just do substitution? Why should I do long division? And you're right. It's really kind of a horse apiece. You could do it either way. You'll get the same answer. But what you'll see when we start to do some example problems is why this is really important. So for the moment, just stick with me. We'll try a couple of example problems, and then I'll explain to you why this is such an important method and why we're making you do it. So head on over to the next page of the notes. We'll try some example problems, and I'll meet you guys there.